Hello everyone, I'll be presenting our work on image retrieval. Let's start with the problem statement. Image retrieval is a key task in computer vision with applications in search engines and recommendation systems. The challenge lies in retrieving visually similar images, especially with variation in object appearance and background. Our goal is to develop such a robust retrieval system, especially for data sets like CIFAR 10. About CIFAR 10, it consists of 60,000 color images across 10 object categories with each image size 32 by 32 pixels. There are 6,000 images per class split into 5,000 training and 1,000 testing images. We experimented with various feature extracting techniques such as SIFT, HOG and edge detection combined with PCA for dimensionality reduction. These features were then used with two classifiers, SVM and K-means. Next, we used deep features from ResNet 50 and applied them with both K-means and SVM classifiers. Moving on with the MLP for classification and retrieval. In this experiment, we again used ResNet 50 features and trained a multi-layer perceptron to classify images into 10 categories. After classification, we retrieved the top 5 to 10 similar images from the predicted class using cosine similarity.
In our experiments, we also used technique like VLAD and bag of visual words. We extracted deep feature using ResNet 50 and evaluated three methods. One was VLAD and the other two was bag of visual words using two kinds of frequency. One was normal count and the other was TF-IDF. The results show that BOVE outperformed VLADs and the results are on your screen. Coming to our part, why we choose bag of visual words over VLAD. Here we compare VLAD classification with cosine similarity that we have seen in previous slides and bag of visual words. Based on several criteria, VLAD is very good in capturing fine-grained details by aggregating local descriptor residuals which help in scenario with subtle visual difference and cross-class similarity. However, its performance comes at the cost of increased complexity and relatively lower retrieval accuracy and also more inference time. In our deep feature based setup, bag of visual words on other hand show strong compatibility with deep feature and achieve higher retrieval accuracy. Although it doesn't capture fine detail as VLAD does, but it balances between simplicity and performance which make it more favorable choice for us to choose. Coming to what exactly is BOVW, which is bag of visual words, the diagram in front of you shows that first we use ResNet 50 for deep local feature extraction. Unlike traditional feature extracting methods like SIFT, HOG, we use ResNet 50 for more robust and semantically meaningful features. These features are then clustered using K-means to create a visual vocabulary we also called codebook. Each image is then represented as histogram of visual word occurrence. We can then apply normal frequency count or TF-IDF count. For retrieval, we process the query image in the same way we do and compute similarity. And what exactly VLAD is, how VLAD is different from bag of visual word is that it skips the histogram step and instead it aggregates the residual, essentially the difference between feature and their cluster center. While in result, in a compact and expressive representation, bag of visual words ultimately give better performance in our evaluation. This slide presents a set of bag of visual word histogram visualization paired with their corresponding images from different classes such as truck, ship, horses, frog, dog, cat, birds and car. Each chart represents the visual word distribution for one image. On x-axis, we have visual word cluster indices and on y-axis indicating the frequency count. For instance, the histogram for truck at the top left we can see that have dominant spikes at the similar cluster indices which implies those visual patterns are frequently activated across truck images. The same pattern can be seen in birds or dogs. Similar images yield similar histogram structures. These consistency across visually similar images reflect the discriminative power of bag of visual words. It turns the complex image data into compact and interpretable format that can be compared effectively. Bag of visual words effectively transform images into feature vector which we then use for similarity matching. Here are results of bag of visual words. We can see that we have two query image, one is bird, and also we can see that the percentage pixel similarity goes on decrease as we increase our rank. That's all about our project. Thank you.